Please welcome Giovanni.
Thank you. So yeah, I'm a postdoc at the University of Ferrara, and more specifically at the Applied Computational Logic and Artificial Intelligence Lab, where we are building this tool called Sole, a framework for symbolic AI. And I was last year at JuliaCon 2023. I presented the framework, and actually I went into formal details, and I presented the motivation for it. Today I'm just overviewing it and reporting some recent developments of it. So very briefly, Sole is an early stage framework for symbolic AI, also called good old-fashioned AI, which is mainly decision tree learning, rule extraction, and random forests and gradient boosted trees, all of those methods that are based on formal logic. Sole in particular focuses a lot on a knowledge representation in form of syntax trees. So the formulas that you can extract and represent within a decision tree are actually represented as logical formulas of some logical formalism. And the cool thing about Sole is that it separates the machine learning model level, the decision list, the classification rule, random forest, and the underlying logical language, which can be propositional logic, modal logic, or first order logic, and so on. We actually started this endeavor 3 years ago because we wanted to extend standard propositional decision trees in such a way that you could make them rely on more expressive logics, such as modal logics of time and space, and then you could basically learn formulas of any logical language. And this is how the modal decision trees package was born. Then the aim at generalization got out of hand, so we started delocalizing parts of this package into dedicated packages, and this is how the core of the Sole framework was born. The core packages of Sole are these three. The first one is a symbolic engine where you can represent formulas of many different logical formalisms, propositional, modal, and first order ones. You can parse and generate, for example, randomly formulas, and you can apply minimization algorithms for simplify them. And most importantly, you can check the truth of these formulas onto pieces of data. When it comes to real data, then you can use the Sole data package for representing formulas that are based on concrete atoms, so that actually have a meaning. And these are formulas that you can actually check on data sets, like normal machine learning data sets, tabular and non-tabular, depending on the logical formalism, which is essentially what a decision tree does under the hood. But not only the decision tree, all of the, let's say, all of the rule-based models, so decision trees, random forests, gradient boosted trees, blah, blah, blah. So the Sole models package allows you to, for example, once you've extracted a machine learning model and you have the decision tree in your hand, to investigate it, to extract rules from it, evaluate it, and also like prune it, merge different models, and play around with the knowledge in symbolic form. Around these three packages, we have been experimenting with algorithms that are sometimes closer to the data, for example, symbolic algorithms for feature selection. Of course, we are implementing a few learning algorithms. These are basically the most well-known algorithms, which are 30, sometimes 40 years old. So we're trying to rebrand them and give fresh implementation of them. And we find that Julia fit perfectly this role. And once you've trained the model, as I said, you can play around with the knowledge you've extracted. So we have been playing with minimization algorithms, and some things that you could do are, for example, you can check that the model satisfies some constraints. You can verify some property of the models. I've put other packages external to Sole, which may relate in some ways. One of them is the decision tree learning package, decisiontree.jl. And so last week I wrote this tiny package which simply converts decision tree learned via this package to Sole compliant models. And I wanted to give you an idea of what you can do with this tool. Sorry? Font size. So yeah, sorry. I would have forgot to ask. So, I hope this, okay. So with the iris classification dataset, okay, so 5 minutes. Okay, so with the iris classification dataset, I split the dataset into 80% training and 20% test. I train a decision tree using the standard package, and this is what I get. So in this tree, if you look at the leaves, it tells you that during training, 30 instances fell into that leaf, and out of those, well, 30 were actually of that class. So this tree basically overfit to the training data. If you look, all of the leaves correspond to high confidence rules. So now I can convert this model into a Sole model, and I can extract the rules. As I said, they are represented in as logical objects, and I can inspect the metrics for these rules. Sorry, yeah, I didn't expect this to happen. So okay, with the last line, I've asked the framework to reduce the size of the rules, because sometimes you can apply some minimization algorithms. And something that is not evident here is that, okay, I'm running out of time, so I will just tell you. There's a column here stating the confidence for these rules, and it is essentially 100% for all of them, and this is because these are the training confidences. But you cannot trust the training confidences, so next time I'm going to call this apply bang function, which is like a predict function, but it also changes the state of the model, so that then when I extract rules from it, okay, yeah, I see the actual confidences on the test set. So one of the rules earlier it had a high 100% confidence. Now it has a 33% confidence, and then I can do other things, like I can join the rules for the same class into something that is well, essentially a DNF, and then I could apply some logical methods to study this knowledge. Okay, so. Yeah, we have been the only user of this framework, but we're basically asking if anyone is interested in this tool and could find a use. We know that it's unique and that the code is mostly usable, although the documentation could use some refining. So if you are interested, we have a bunch of material, and if you want to know more or contribute, please reach out. Thank you.
Thank you, Giovanni. Anybody from the audience has any question on this expert?
So in this symbolic language, is it mostly Boolean operations and greater less equal comparisons, or what are the syntactic elements of this symbolic language?
So with the propositional language, it's mostly Boolean operators, and you get to choose what kinds of atoms you want. For example, you said you know, atoms can be as simple as a simple thresholding, or if you look at the rightmost one, that's like linear combination of, you know, that's called a unique oblique atom, because it's multivariate. So you actually get to choose that, but you have to have a learning algorithm that extracts that kind of formulas. But we've designed also algorithms for extracting more than propositional formulas, like temporal formulas for time series or spatial for images.
Thank you very much for the talk. What other parts, I mean, the landscape of symbolics and logics is very broad. From, I don't know, you mentioned higher order logics, description logics, whatnot. So what does Sole logic actually cover, apart from decision trees and more sophisticated decision trees?
So it was built with machine learning in mind, like for representing formulas that you would extract with the decision tree. And then we generalized it. So I think I'm not sure I found something that would fit exactly what we were trying to do. I would say that the machine learning oriented view is the novelty. Let's say you can check out the documentation, and maybe we can talk later if you would like.
Let's give one round of applause.
Okay.